All right. So, welcome back again. Now it's time for a more hacking-focused session. Not so much about solutions, but more about the potential threats that are out there, how malicious code works. I think that's still extremely relevant for developers to know, to understand how attacks could potentially be performed, and that makes us think in a different way when we develop our own systems and our own apps in terms of protection. So I decided to call this session Making Zombies because that's pretty much what this is all about. Taking control over the targets. So zombies, usually that means something like an animated corpse raised by magical means, but that's not what we're going to talk about here today. Pretty sure someone would fancy that, but instead, in this context, we mean software that's somehow, software or even devices that's somehow controllable by hackers or by malware, or by hackers through malware and so forth. So I'm going to do hopefully 3 different demos. We'll see about what time permits, but at least 3. We're going to start with the Android platform, watch how an application can become root, and what the effects of that is. Pretty sure everyone understands what it would mean if someone gets root access, but still it's interesting how easy such attacks can be performed. And I noticed that quite many of you are web developers. Are there anyone who develop hybrid applications for mobile devices? Well, there are some. Interesting. Because that's an interesting area from a security point of view. It's, of course, something that's extremely powerful if you want to target multiple client platforms without developing specific native apps for each of the target platforms. The second part of this presentation will focus on the OS X platform. I think many of you use Mac OS X as a development machine. How many of you use Mac OS X, by the way? Yeah, so about 50%, 40-50%. I use Mac OS X myself. Many of my colleagues do too. It's a nice environment to work with, especially if you do, for instance, of course, iOS OS X development, but also for Android and other stuff. A few words finally, not only on the root pipe exploit that I talked about before, but also on some physical access attacks. And we start with the Android platform. And just to give a really brief overview in case there are people who have never heard about this before, this is probably not something new to Android developers at least. But a brief introduction to Android security is that applications installed on a device will get a separate Linux account assigned to them. So that's sort of a kernel level sandboxing, and quite a good approach actually, because that means that files being read or written for that specific application will only be readable and writable by that Linux user account by default. So And then, of course, there are different ways of sharing user accounts between applications in case they're assigned by the same certificate and things like that. But we don't need to go into the details of that. This is also used for some of the permissions. For instance, applications requiring the internet permission will also get their application their application user account added to the group, to the Linux group that has access to network communication. So that's another way of utilizing what's already in Linux and not having to invent something from scratch. Because, of course, if the restrictions for internet permission would only be on a framework level, then it might be a possibility that someone else, some attacker gets the opportunity to execute native code instead and circumvent the permissions model in that case. So I think that's a good approach. In addition to regular apps, we also have some system applications that operate with slightly higher permissions, usually running as the system account instead. And finally, we have the system software where normally no applications have full access. And there is really no reason why applications should have access such as root, because that means control over the complete device and the ability to flash new firmware and things like that. So privilege escalation in Android means going from the application sandbox to possibly only to the system account level, but usually going even further and becoming root. And that means getting control of the system software. One of the problems, there are good benefits with this design, but the problem with this is that, for instance, if a user would initiate a factory reset or a remote wipe of an Android device, that would mean wiping the user data, but not wiping the system data. Because by design, there shouldn't be any way to modify data in the system partition. And of course, that's a big issue. If an application gets root access, that means that such software could actually survive a factory reset. And there's no good ways around that except replacing the hardware. Could possibly, of course, it could be possible to flash new software if you know that the software can be trusted and things like that. But that's not something normal users would do. So we're going to look at an application getting root access. It's just simple installation of an application. The application will, when started, immediately run an exploit to get root access. And this works on Android up to 4.4.2. And we're going to see that on this device that I have with me, we actually have SE Linux running in enforced mode, security enhanced Linux, that is. And let me switch to camera here. I just made a search for software updates, and as you can see, there are no additional software updates available for this device. So the latest updates have already been installed. Okay. Guess there's not much we could do about that. I know that it might be a bit difficult for people in the back to see all this, but this is Android 4.4.2 and SE Linux running in enforcing mode. and this device is a Samsung Galaxy S4. Maybe you heard about Samsung Knox. Samsung Knox is also integrated in this device. And let's see, so I can't show the computer and the device at the same time, but let me show you how we'll switch back quickly. Let me show you what's done on the attacker's machine. So here's the guy with the hoodie again. We'll just start netcat. You've already seen other examples of this previously today, where we create a reverse shell. But and the point with reverse shell, if you missed that point, the point is going through firewalls and having traffic that's initiated by the user rather than from the outside. So that makes it working through firewalls and things like that. So let's see if we can go back. We leave that in listening mode on port 363. And we'll run my cool puzzle application. And this is just, as you can see, I'm not the GUI guy, but I try my best. See if we can make this match. I'm missing a piece. It's outside the screen. Let's see if I can rotate. It's there. Ta-da. You see, I didn't think of that. Should have spent more time on developing this demo. So, going back to the attacker machine, see if anything happened. Nothing happened. See if we can issue a command. Yes, we can. So we can see that we have a reverse shell connected just from the fact that the user installed and ran this application. From this point, the user could possibly go ahead and just erase this worthless puzzle application in case they didn't enjoy it. That doesn't matter because we're already operating on a system level. So we're no longer dependent on the sandbox. But as you can see, this reverse shell is running as user account 10,201. So that's automatically generated user account when the application was installed. And you can also see that the group assigned, there is a group assigned 3003 for internet and some other stuff. But there are still, of course, limitations to what that user could do. So for instance, under /data/data, we have the sandbox data for each of the applications, but we don't have sufficient permission to look there. Except if we do SU, because then we'll be root immediately. Of course, SU is not included by default. That would be catastrophe. But it might actually be in some of the custom ROMs out there. But then usually if you run SU, then there will be some kind of user interaction where the user will be required to accept this so that applications can't get root access without the user's permission. So from now on, now there is no longer any problems listing all the sandboxes and jumping into, let's say we jump into the sandbox of the puzzle that's still there. And here's really all the sandboxing data available. But it's not only application data that might be relevant. Starting Android 4.4, there's actually a utility included by default to record what's on the screen. How awesome is that? Of course, this is normally something that you can only issue through ADB or by being root. Fortunately, we are root right now. So there is a built-in toolkit for recording what the user has on the screen. And I'm not going to record what's on the screen and show you all this and that. I mean, we could record what's being captured by the microphone and everything, send SMS messages. I think you get the point. This is complete access and complete control over the device. And well, there is actually one thing we could look at if we can get the device to hook up to this again. See. We could look at, I mentioned SE Linux, security enhanced Linux. A way of checking where the mode of security enhanced Linux is calling get enforce. And you can see we're now in enforcing mode. Usually you run SE Linux either in permissive mode or in enforcing mode. If you have it in permissive mode, then that's basically like logging and recording everything that happens. And you can use that and later run those rules in enforcing mode so that you accept certain operations that applications make, but nothing more. So enforcing mode is the strongest mode, and permissive mode is more or less turning it off. So the problem with this is that root can just call set enforce. Oops, I'm not root, by the way, I forgot. Set enforce 0. Ta-da! And it's no longer active. Which means that, of course, having a security enhanced Linux as part of Android is a good thing, but it doesn't protect against attacks from the root space. Let me see if I can find my slides again. Boop. So what about hybrid apps? I think many of you have heard about hybrid apps before. It's basically a web application running inside a native app container. And the native app container can look a little bit different depending on what kind of framework you use for hybrid app development. Common frameworks is PhoneGap or Cordova, and that's used for developing applications in HTML5 and JavaScript, packaging those applications in a web app container or in a native app container, and after that you're able to run the same application basically on several client platforms. That HTML5 or JavaScript content could get loaded locally from inside the application package, locally from a file stored in the sandbox, for instance, or content loaded over the network. In, I think it was in Android 4.2, this is not an exact science because some of the OEMs, they backport certain fixes that are of high priority. But somewhere around 4.2, they fixed a vulnerability in Android WebView, which is used in hybrid applications to load web content inside an app. WebView was actually also used in the Android browser. So, and the scary part of this is that, I mean, this is a vulnerability as any other, except from the fact that Google would need to maintain compatibility somehow with applications that hasn't adapted to the fix. We're going to see more about how that looks. But just to explain why this is possible, there is by design a possibility to add Java objects in JavaScript that's going to be available in JavaScript. So you don't add it in JavaScript, but in your Java code, you have access to your WebView, you call a method, add JavaScript interface, you send in the Java object you want to have accessible through JavaScript, and you send in a friendly name for that. And you can later on, in your JavaScript code, use that name to refer to the Java object. JavaScript Java object. I think you get the point. Sorry for messing that up. So if that Java class has a method called myAppMethod, then we can call myAppMethod from JavaScript. What they didn't think of when designing this is that it actually enables all methods, even the inherited methods. For instance, the inherited methods from the class object, which means we're able to call getClassLoader to get a class loader. Think about this, getting access to a class loader from JavaScript. And later on, with some limitations, just from the fact that there's a difficulty in passing arrays between Java and JavaScript, you're still able to call basically anything, or at least the important parts. You can instantiate or get access to runtime, get runtime, to get a runtime object, and then you can invoke the exec method on that. So this was fixed by requiring annotations on all the methods that should be accessible through JavaScript. And I have a simple hybrid app example that loads a hello world, excuse me, hello world web page. Again, I'm not the GUI kind of guy, so I'll try my best. I think you get the point still. The attacker has some kind of ability to modify the content being loaded. That could be through man-in-the-middle attacks. It could also be through cross-site scripting or any other way of modifying content being loaded. So let's have a look at that demo too. We'll use Netcat again, but on a different port, just to avoid collisions. That happened before on stage, and I don't want that to happen again. I want to run into other issues with my demos. So, see if I can switch. This doesn't work. Let's do it in the emulator instead. It's going to be a lot easier. At least I thought so. Any questions, by the way? You're just silent. Just asking if there are any questions, since I need some time to boot the emulator. Well, it is a big issue. Yeah. Well, maybe not. Maybe I'm not sure if the law the European Union laws would be applicable. I'm not an expert in that field, so I mean there was some stuff in the media, but maybe it was more in the security-focused web media and things like that. Because this has been known for some time, the WebView vulnerability. But of course, it is a big issue. It's especially since it's accessible through the browser too. That means that just by visiting a web page, any web page on the internet, an attacker could load native code into your application process or the browser process and steal cookies and stuff like that. So that's a really big issue, of course. Let's see if we are at better luck with this one. That's my sample app. Hello world. So it loaded something at least. And you can see the spinner from the Python simple HTTP server that it connected to. So something worked. Yep. So we could actually have a look at the source for this. It might be of interest. Give me a second. So, as you can see here, there are some adaptations specifically for when I run in the Android browser context, since I want to use the same JavaScript code for demoing whether I'm in a browser or in a hybrid app. But as you can see, it's really simple. It's not that much code required, just to get runtime, and execute a reverse shell using netcat connected to a certain IP address. So that's really simple. Too simple. And from here, of course, if we do a comparison to what we found before, we still have restrictions of what we can access, but I would expect... sorry, I'm not I'm not in the browser. See what's SC TrueSec. Wait a second, so I don't screw up here. Wasn't it? I should be able to. Maybe I need to. Let's try one more time. Hybrid test. Probably missing something. I think you're right. Yeah, you're right. Awesome, thanks. So let's Try it one more time. Whoops. Demos, hybrid, ta-da! So, and if this was exploited in the browser, then of course we will get the browser sandbox instead. So that's why I messed up in my head. But and getting access to a hybrid app or a browser sandbox, that also means we have access to cookies used in WebView and things like that. Application cache, anything. So that's of course a big problem. And but going back to what you can do as a developer, you can verify that the target SDK version is 17 or higher. Because if you have, then you make sure that you have annotations required for JavaScript access. So that means that all methods have to have the annotation JavaScript interface. And also use TLS when loading content in your hybrid applications. If you're loading content over the web, then TLS is recommended. So, going over to the Mac platform, there are some built-in protection mechanisms like Xprotect, Gatekeeper, FileVault, and all that. Xprotect and Gatekeeper is on by default. You could modify the settings of Gatekeeper depending on the usage scenario. FileVault, we use FileVault. I really recommend using FileVault because otherwise you're at risk with physical access attacks. There are different types of user accounts. These are the most common. There are a few other types, but the important types to remember is standard and administrator. If you don't specify anything specifically when you install a Mac, then the first user of the Mac will become administrator. And still, that user would be required to supply their password explicitly each time they do an elevated operation using sudo, for instance, or if they modify sensitive system settings, such as adding new user accounts to the system and things like that. But there is an ability to run as standard user account as well. I really recommend using that instead because of the reasons I'm going to show you quite in just a few minutes. And being root on an OS X system means root as any other Unix-based system. So if you do a system setting change, then you will need to supply your username and password. And that is, of course, a username and password for an admin account. So if you're running a standard, then you need to supply an admin account. There is also ways of storing credentials and other sensitive data, such as private keys, for instance, for code signing. Keychain is really the core part of the operating system for doing that. Everything stores the secrets there. And that's, of course, good to have some kind of secure container for secrets. The bad thing is that if someone gets access to the system, they get all your secrets. So I'm not saying that you shouldn't use Keychain. I'm just saying the fact that if we have complete access to the system, then we might be able to steal the keychain. For a user, the keychain for user-specific data, the keychain data is encrypted using the user's password. For system-specific stuff, it's encrypted based on a system key. Unfortunately, if an attacker becomes root, then the attacker could get hold of that system key, because that's just a simple file under /var/db/system key. That's the encryption key being used for storing and reading secrets from the system keychain. So root pipe, It was actually during the preparations of the demos for today, and also for Security Summit in Stockholm that was about a week ago. I started digging into some internals of macOS X to find a nice demo where an attacker becomes root in an OS X system. It seemed very hard from the beginning because all the exploits I could find on the internet were too old. So I thought in the back of my head that if I present something like this, people are not going to take it seriously, because they're going to think that, well, it doesn't affect me anyway because my system is patched and everything is, so that's irrelevant. But fortunately, I found root pipe instead, so I had something that I could demo on 10.8, 10.9, and 10.10. 10.10 was in beta by that time, but the final version of 10.10 is also vulnerable. This was October 2nd, and I reported it to Apple the day after. And we're going to look at the demo of this. So we need the attacker machine again. Let's just exit the shell and use a new port. Something like that. And we need the user as well. He's running his screensaver right now. And root pipe is a local privilege escalation. That doesn't necessarily mean that an attacker would require physical access to the machine, but they would require some way of executing code on your system. One way of achieving that is through physical access, and go ahead and type into the terminal, download and run the program. Another way could be utilizing browser vulnerabilities or PDF vulnerabilities and things like that. That would also give us the ability to execute code on the system. Another way is documents using macros. So this is an Excel sheet that I just modified slightly with some statistics on Android applications that don't validate SSL certificates in a secure manner. This was results from an automated test, so this is not the exact truth, but interesting anyway. But maybe it's not that interesting. It might be more interesting to look at what's going on the attacker's machine. So we see we're root, and we're on test user 1's Mac. And looking, for instance, as I mentioned before, we have the Keychain system key for the Keychain. And as you can see, that's only readable by root, but that's not an issue in this case since we are root. And this is, I mean, now you probably see that all the Unix-based systems are quite similar, that there are good security boundaries built into the system, but as soon as you become root, then that doesn't apply anymore. In OS X, there is actually a least privilege model, which means that there are still some protection left, but still, the file here and the system keychain is all we need to extract keychain data on a system level, not the user-specific data. For the user-specific data, we would also require to brute force the user password. But we have access to the user password hashes, so we could start brute forcing them. But still, there is some protection related to what a user has to type in, and I think that's good. But from here, we can basically modify the system in any way we like. We can add user accounts, of course. We could start SSH if we want to. Yeah. So this is pretty much all access we need. Let's go back to the slides. So I already talked a little bit about the attack vectors possible for this. I think that this would become a big problem if it got combined with a client-side vulnerability like remotely exploitable, like browser exploits, or for instance, exploits related to decoding of images and PDFs and things like that. But there is more root access. Maybe someone knows this in the audience. Now it's your time to show. If I find a Mac, let's say on a bus in Malmö, is there any way to get access to the data on that machine? Simple way. Ta-da! There it is. Single use mode or recovery mode. It's extremely easy to just reboot the system and jump into single use mode or recovery mode. From there, you are root by design. So, recommendations. Run as a standard user if it's possible. I understand that it might be a mess if you're a developer, especially if you're a developer using on iOS or OS X. But try to investigate if it's possible in your daily work to run as a standard user rather than the admin user. And activate File Vault. There's really no performance penalty in using File Vault. And if you use File Vault, then you're not exposed to the attacks like single user mode and recovery mode. Because if you reboot the system into recovery mode or at least into single use mode, you'll have to log in as a valid user anyway. But if you don't have File Vault, then someone could just reboot the system into single user mode. They could reset the password for the root user, for instance, and reboot the system again and log into Mac OS X as the root user. And they wouldn't be in need of getting access to your credentials. Of course, they could, reset the password of your user as well, but that you would probably detect that, right? And keep your systems updated. RootPipe is gonna be fixed, hopefully. I mean, I'm not the Apple representative, so I can't promise anything. But I'm pretty sure they'll take it seriously and fix this. And if, as soon as they do, update your system. That's of course not something specific to RootPipe. That always is the case. Update your systems always, and of course always in Android also. But we've seen that in Android it's quite complex, that it's not always up to us to patch the system because it's up to the OEM, and sometimes in some countries at least it's also up to the carriers to publish an update to the end users. That's it. Any questions? No applause yet. Any questions? Yes. You'll have to speak loud because I'm. Yeah. Sorry. Mm-hmm. I see what you mean. So the question was, how do we detect this? Are there any tools available for Mac to detect that someone got root access of our machine. Not that I know of. There probably is, but I haven't seen any. But of course, that's always a race with these types of tools. That I mean, if we have complete access over the system, then of course we can intercept the calls being made by such tools. But yeah, I think there would be, I mean, to the level of how my proof of concept code works, it would be definitely possible to detect that something has happened. But in advanced threats, then they usually handle it in a different way. They don't do reverse shells interactively and things like that, and they try to hide it in a more efficient way than I tried to do. So well, it depends on what you're developing. I'm not the go-to guy, definitely not the go-to guy in terms of web development. You should ask, for instance, Fabio, Jimmy in the back of the room, Stefan. There are several others that are more into web development. But there... Oh, sorry. Yeah. Yeah. Yeah, I see. So maybe I didn't answer your question sufficiently, because that was my interpretation. But in embedded systems, for instance, there are a lot of stuff you could utilize in your development, like packs, GR security, kernel hardening, and things like that. If you're on a Linux-based system, there is something called app wrapping for mobile applications, especially, but that's more used in like line of business applications, enterprise environments of mobile apps. So I'm not familiar with any. I mean, we do a lot of development of secure app containers or something similar, but I'm not familiar with any open source products like that. Not that I can think of, at least. Help me out, my colleagues, if someone can think of it. No? Sorry for not having a good answer on that. Yeah. We have another question. Yeah. That's a good question. So, what's the purpose with SE Linux? We have SE Linux running on this device, but we're still able to hack it. That's actually something I asked Samsung the last time I met them. So why am I still able to hack your device if it's like bulletproof, as you claim? Yeah, I mean, with security enhanced Linux, it still serves a purpose, because if it's running in enforcing mode, then there are some limitations to what you can achieve. But again, of course, we can always disable it. And Samsung actually implemented, I didn't show that in my demo, maybe I should have. They implemented a small user notification saying that, whoa, SE Linux is now disabled. That's probably a bad thing, or something like that. So you should be aware of this, that the security has been decreased somehow. But of course, again, we have control over the software and we have control over the device, so we could wipe out that notification. So there are probably some thoughts about this, and so I think it's a good thing that SE Linux has been integrated in Android, but maybe we need more stuff. I think that this is, I don't have the solution, but there are things that I've thought about a lot, especially this year, when doing hack demos like this, is, I mean, why am I even possible? Why am I even able to run Netcat from my application sandbox, or write binaries in my application sandbox and load them dynamically? Why is that even possible? Compare it to iOS, for instance, where we have a code signing requirement where everything that gets loaded has to be code signed. That's a different way of looking at security. So I'm not saying that iOS is perfect in all scenarios, but on that area, it's slightly better, in my opinion. But at the same time, jailbreaks, some of the jailbreaks lately have actually been using signed code. So they have just used enterprise code signing certificates instead. That's normally used for line of business applications, and they use that to sign jailbreak code. So of course, it doesn't necessarily mean that there aren't ways to circumvent that. So I think the freedom of an Android application, maybe it should be somewhat limited on a system level. But again, both the demos I showed on Android, they are fixed, and the biggest issue with the WebView demo is that it depends on the target SDK version. So if you have a target SDK version set to 16 or lower, that would mean that it still doesn't require an annotation. So it's still possible to execute code, even on the latest versions of Android. Well, I haven't tested on 5.0, but on the latest 4.4 software. And of course, that's always something that you have to consider, backwards compatibility towards security. I know that there has been some activity in Google Play, that the Google Play staff notified developers about applications that has this problem. So they actually notify developers and tell them, you should really raise the target SDK version to something like this instead, to avoid attacks. So I think we're out of time, very much out of time. But we're gonna have a short break at least. See you back here at 3. Thank you.